Welcome, dear students, to Standard 7 Science. This is teacher Sharon De Silva, and we are discussing chapter number 17, Effects of Light. When sun's rays pass through a glass prism, what are the colors in the band of light seen on the other side of the prism? This, my dear students, is a glass prism. When sun's rays, as you can see, there's a ray of light passing through this. On the other side, something like this, a rainbow is observed. You have learned that light is composed of several colors. You must have also seen the dust particles in a beam of sunlight entering the house through a small window. We switch on the headlamps of a car when we drive through a thick fog. You might have seen the beams of those lamps. What do we really see when we see a beam of light? We see tiny dust particles floating in the beam. That is why we are able to see the beam of light. We see a variety of shades of color in the early morning and evening sky. If the photographs taken from space by satellites, in the photographs taken from space by satellites, the earth appears to be bluish. What is the cause of all these effects? Have you ever wondered? The phenomenon is called as scattering of light. Let us see what is scattering of light. In order to understand scattering of light, we need to understand this particular experiment. The apparatus required for this experiment is we need a glass beaker, a diode laser which is also known as laser pointer, water, milk or milk powder, spoon, dropper, etc. Exactly what we do, we take clear water in a glass beaker, pass a beam of laser rays through it. Check whether the beam is seen in the water. Now use the dropper to add a few drops of milk to the water and stir. The water will be seen to have become slightly turbid. What is the meaning of turbid? Turbid means milky or dirty. Now pass the laser beam into it again. A light beam will show the existence of light rays. A light beam is not seen in plain water, but is clearly seen in slightly turbid water. The light rays hit the tiny particles of milk and get scattered. If these scattered rays enter our eyes, we perceive the light. What happens is, earlier this particular beaker had only clear water. So if we tried to pass the laser, we couldn't see the light rays. But when we added milk, it became turbid or it became dirty. And the milk particles were mixed in the water. When we tried passing the laser now, the laser beam or light hit tiny, minute particles and it scattered, means it spread out. And that spread out light we could see then. That is called as scattering of light. And that is how we perceive light. That is how we see light. So we see light when light gets scattered in all the directions. That is how when light hits a particular surface and it gets reflected and scattered in all the directions. That is how we see light. When the sun rises, our surroundings appear illuminated. The entire sky appears bright. This happens because of the dust and other tiny particles in the air. This is the scattering of sunlight by the tiny particles of the various constituents of air. Imagine, had there been no atmosphere on Earth, the sky would have appeared dark during the day, and of course, the sun would be directly seen. Now, this has been verified by observations from rockets and satellites which go out of the Earth's atmosphere. So we see everything around us because there are tiny, tiny dust particles around us. So when sun's rays touch these tiny dust particles, they are reflected or scattered in the light rays are reflected or scattered in all the directions, and that is how we see our surroundings. Otherwise, if there were no tiny dust particles or if there was no atmosphere in around us, the sky would have appeared dark and it would have been difficult to see things. Now there is another experiment which we are going to perform. Let's see what this is. We need a table lamp, the 60 or 100-watt milky bulb. An LED bulb will not do in this case. Thick black paper, sticking tape, a packing needle, 100 to 200 ml glass beaker, milk or milk powder, dropper, spoon, etc. This is how the apparatus will be placed. Let's see what exactly we are supposed to do. Cover the mouth. This is the mouth of the lampshade. So cover the mouth properly with black paper using sticking tape. Prick a hole somewhere here of 1 to 2 millimeter diameter in the center of the paper with the help of the packing needle. Take clear water in a beaker, light the bulb and place the beaker in contact with the hole. So the beaker should be, just a minute. The beaker should be placed exactly in front of the lamp. Observe from the front at an angle of 90 degrees. So we are going to observe from here, from the front. Now add 2-3 drops of milk to the water and stir and observe again. A few drops of milk may have to be added to make the water turbid. A blue tint is seen when observed along the 90-degree angle. This is the scattering blue light. Because the blue light is scattered, a red-yellow light is seen from the front and the whole appears reddish. A few more drops of milk are added. The reddish color seen from the front becomes an intense red. However, if many more drops are added, the reddish color is not seen. Why is this so? Sunlight is scattered by the molecules of gases like nitrogen, oxygen in the atmosphere. The blue color in the sunlight is scattered the most and therefore the sky appears blue. Sunlight reaches us through the layer of atmosphere. At sunset, the light reaching us travels a greater distance through the atmosphere. Due to the greater distance, there is more scattering of the blue color. As a result, the red-yellow light reaches us directly and the sun appears red. Red light is scattered less than blue light. My dear students, we will stop here. Please read your textbook. We will meet in the next video. Till then, thank you for watching. Have a nice day.